I request our moderator, Mr. Abhijit Mukherjee, Director Operations, Indian Biogas Association, to kindly come and join us on stage. Ladies and gentlemen, please put your hands together for our moderator, Mr. Abhijit Mukherjee. Please show some energy. It's the last session. Thank you. And now I request our panelists to kindly join us on stage. I request Dr. Sangeeta Srivastav, Executive Director, Godavari Biorefineries, to kindly come forward and join us on stage. Once again, ma'am, a very warm welcome to you. I now request Dr. Sujukta Subudhi, Associate Director from TERI, to kindly come forward and join us on stage. A very warm welcome to you, ma'am. We also have with us Mr. Bhima Shankar Shetkar. Sir, I request you to kindly come and join us on stage. Mr. Bhima Shankar Shetkar, Chief Operating Officer, NDDB, Brida. I request Mr. Shantanu Agarwal, Executive Director, Bharti Waters Private Limited, to kindly come forward and join us on stage. A very warm welcome to you, sir. I now request Mr. Gaurav Kedia, Chairman, Indian Biogas Association, to kindly come and join us on stage. Once again, a very warm welcome to you, sir. I request Mr. Nishant Sarna, Senior General Manager, Maruti Suzuki India Limited, to kindly come forward and join us on stage. I also request Mr. Ravi Mathur, President Teert Agro Shaktiman, to kindly come forward and join us on stage. A very warm welcome to you, sir. Ladies and gentlemen, please put your hands together for our esteemed panelists for the panel discussion on biomaterials, plethora of opportunities and possibilities. Please put your hands together. Thank you so much. Over to our moderator.
So hi, good evening all. So I'm Abhijit Mukherjee, Director, Indian Biogas Association, and I would be the moderator for this session, that is biomaterials, plethora of opportunities and possibilities. So being the last session, I think the energy is already drained out, but I will try to keep it as crisp as possible, right? And I will try to rope in my panelists with their expertise, wide and diverse experience that they have. So I will try to rope in as the session progresses. So even before getting to my panelists, I would like to set the context a little bit, right? A very crisp context setting. So over the last decade, we have seen that there has been significant improvements or significant efforts that is being made towards climate change mitigation, both at national and international level. And within this scenario, it is becoming more and more inevitable for all of us to adopt cleaner fuels and the sustainable biomaterials in the overall mix of things. So we are all intending to move towards a non-fossil based economy. At least we intend to do that. Of course, within this scenario, a lot of positivity is there already in the ecosystem, and a lot of credit has to go to the ministry for all the efforts that has been made, a lot of policy interventions, rightful policy interventions, which is making the ecosystem or the business ecosystem ever so conducive. So hailing from a biogas industry means I will speak more about, a little bit more about the biogas. So biogas has seen its progress across the value chain. More so, one of the interesting things that has happened in the field of biogas is in the downstream side. So in the downstream side, we are seeing significant advancements so far as the fertilizer or the fermented organic manure is concerned. So we are seeing the fertilizer marketing companies now coming forward. So they are coming up with their tenders. They are participating not as much as we are anticipating or expecting, but they are coming up with tenders. They are procuring at higher volumes. Now, a lot of fertilizer marketing companies are coming up, and that is giving the room for even more value-added products like the PROM or the CROM or the NP CROM. And even one of the products that we are now talking about is the biochar from the fermented organic manure that happens with gasification of this. Biochar as such has got even more wider applications. It is used not only as an organic enhancer for the soil, but it can be used as a precursor to a lot of biochemicals. It can be used as a catalyst. It can be used as a cleaning agent. Likewise, carbon dioxide, one of the gas that is going largely unharnessed in the bio-CNG plant or CBG plant. So that has got a wider application as well. So in one of the feasibility studies that we have been doing in the southern parts of India, we could figure out that this carbon dioxide, one of the lowest hanging fruit that can be there from, or the easiest way to apply this carbon dioxide would be transforming this into dry ice. For example, for transporting the perishable goods like the fish or such kind of perishable goods, you can use the dry ice. Of course, it would require a little bit of capex to be introduced. But having said that, carbon dioxide is also catching its fate. We are not having so much of use cases as of now in India, but definitely it is catching up. Coming particularly to this topic of biomaterials, I believe biomaterial, as we know nowadays, it is more than the niche way that we know that it caters mostly to the packaging industry. Of course, it caters to the packaging industry, but now we are seeing wider applications, maybe in the healthcare industry, in form of the implants that happens. We are seeing applications in the food processing industry, even construction industry. To my surprise, there is a lot of mycelium-oriented bricks that is also finding its feet. And likewise, biotechnology or the biosimilars in the pharmaceutical industry, there is a lot of application in the biomaterials. One of the challenges that definitely is there with the biomaterials is the financing. Financing has always been an issue in a sunrise industry. So, means the financial institutions typically would be looking for proven track records to kind of put in more money into the ecosystem. And right now, this being a sunshine industry, the financial institutions might be a bit skeptical with respect to introducing funds. But having said that, I think things have improved. We are now seeing the financing institutions or the banks having a product being carved out for the CBG industry. Almost all the commercial banks, at least the public sector banks, have now a product carved out for lending to the CBG industry, and likewise for the biomaterials. So with this being the context, we know there are opportunities, but there are challenges as well. So I will now rope in my panelists with their thoughts, and I would like the discussion to be focused on majorly 4 pillars. The first pillar being the science and innovation bit of it. The second one being the scalability and the commercialability. So we are seeing a lot of pilot scale efforts that has been made, but scaling that and commercializing that. How do we ensure that thing to happen? Then the policy interventions, like rightful policy interventions. And last bit of it is the business viability, wherein we take into account the social impact part of it and how we can encash it to kind of make the businesses viable or to pitch it in a more interesting way for the investors. So having said that, we will do a first introductory round of the panelists, right? So maybe you can introduce yourself, your organization, and a bit of opening remarks. So we'll start with Mr. Ravi, and then we will move from there.
Yeah, good evening, everybody, and good evening to every person who is interested to hear our talks over here. I'm Ravi Mathur, I'm representing Shaktiman, and we are a pioneer, we can say, in a crop residual management industry. So here I will be putting some lights on it, how we as a manufacturer of crop residual management, how can we support the industry to bring it to the next level? Thank you.
Hi everyone, I'm Shantanu Agarwal. I'm representing Bharti Waters and Hego Biotech. We are working in hydrogen sulfide removal with biogas plants, and this is one of the important aspects in the whole purification value chain. So we have been helping our customers achieve 0 ppm H2S, which also protects their assets, which is the biogas plant, and eventually they are able to get the right quality bio-CNG, which can be an efficient energy source. And yeah, I look forward to this panel discussion today.
Hi, this is Gaurav Kedia. I'm Chair of Indian Biogas Association. I also look forward for this panel discussion.
Very good afternoon to all. I am Sanjukta Subudhi, leading this biofuel and biochemical vertical at TERI. So we work on technology development and demonstration at a pilot scale for multiple portfolio of biomolecules. All those biomolecules that can be produced through use of the microbes as a cell factory. Going forward, I will highlight what are the key concerns and what is the need for currently for the chemical industries to look for the biochemicals and biomaterials. Thank you.
Good evening. This is Sangeeta Shrivastava from Godavari Biorefineries, and I am Executive Director in Godavari Biorefineries. We are an 80-year-old company, and we've been into this business of biomaterial, biochemicals, and biofuels since many years. World started looking us differently, but we've been doing this, and maybe I'll bring out some experience while we discuss.
So thanks, panelists, for the introduction. So now I will get back to Mr. Ravi. So you are involved in agro-residue-based biomaterial production, right? So with respect to the current scenario of the infrastructure or the supply chain that is existing in this particular ecosystem, where do you find the gaps to be prevalent, and what efforts has been made to kind of bridge at your organization level or at government level? If you can throw some light on that.
I would request the console to exhibit my one slide I had made actually, just to bring around what kind of opportunities available on the crop wise. If I talk about our paddy straw, we have roughly 180 million tons of straw available over here. And if a farmer wanted to earn anything, he can earn 1,500 to 4,000 rupees per acre. That is per season over there. And if I talk about the sugarcane thrash, almost 120 million tons are available in an Indian field. And if I talk about the cotton stocks, it is available in the tune of 30 million tons. I'm just putting this data to have a context for the discussion where we can see the opportunity and we can address the challenges also with the panel expert. Then if you talk about the wheat straw, it is almost 110 million tons. Maize trover is actually close to 45 million tons, and cotton husk is almost 15 billion husk annually. Groundnut is 6 to 8 million tons, and banana fiber, which is 5 to 6 million fibers, potential is available over here. I think both of us, it is there available. And actually it is not legible, we have to see at the back. I just missed out to give you the handout of it, and that I will do. So now coming down to the thing is that I always talk it as a waste to wealth. We had actually now worked in a linear economy. Now the economy is becoming a circular economy, where we can earn from lot of things from the waste. And if you go to the second last column where the industry is already using it, is the paddy straw are used in a biofuel plant, thermal power plant, paper mill, and packaging industry. And which is very less known, I will talk about the banana fiber where the textile industry started using now. And this is also used in the eco-friendly packaging. Now the paper has been replaced with this kind of a fiber content over here. And cotton husk is the second least known. It is used in the mattress industries and all. If I talk about the basic challenges in the biomaterial is that, first is that efficient collection of the biomaterial. Almost 40 to 50% material destroyed, decomposed at the ground level only. So we build that kind of a machine which is exhibited over here. And I think in my concluding remark, I will be able to show you some video where the audience can visualize how that machine works and what kind of efficiency it can deliver to it. And second challenge is that what is the logistic arrangement for this biomaterial which is being collected from the field. Third is the infrastructure for the storage. Fourth is technology scalability. We have seen a lot of institutions who are working in the same scale over here in the pavilion where we are coming. And last but not the least is the farmers' awareness and the supply chain. So these are the challenges over here. But first thing is that which I am addressing, the efficient collection. You want? Actually, it will come on the stage. It is a factor. We will not able to hear it clearly. The audience will able to hear clearly. You just reduce the echo so that we will also able to hear it.
So if you can
Slightly lower down the echo, now everybody can hear it. It is actually stage factor is there. So this is there, and we have a entire, I can say, a value proposition for the collection. We have a slasher is there, which thrashes the content of the biomaterial, which is applicable for all the crop which has been exhibited in the slides. And there is a mulcher is there. For specifically for the maize, we had made a shredders, which is used in the moving field also. And we have a raker, which align the crop for getting the efficiency of a balers. These all equipments are meant for the really, I can say, collecting the raw material from the field and bringing it to the storage location. And last, which the picture is exhibited over, is a silage baler, which is mostly used for the packaging of the straw, which is mostly used for the silage industry. So this entire value chain proposition is for the procurement and transportation of the material from the field to the warehouses.
Okay. So thanks for introducing to your wide array of products that you have. My next query would be to Santanu. So considering the diversity of biomaterials that we have, right? So there is a gamut of biomaterial, and your experience in the industry, you might have been in touch with several medium scale or small scale producers, right? So what efforts are being made at your end to kind of ensure that the awareness, proper awareness about the products happens, and how the compliance, how the standardization of these biomaterials are actually coming up? Has there been any effort made towards standardization? Like in the CBG industry, from which I hail, there has been quite an effort to standardize at least the specs, or maybe the designing aspect, the operation aspect. So what efforts has been made so far as the biomaterial ecosystem is concerned?
Thank you. So you have very rightly mentioned that there are a lot of biomaterials which are available in order to produce biogas. But one has to be very careful when designing a system, because typically a biogas plant, it will be located in a region where the feedstock is more prevalent. So I don't think that one design can fit all. It's very important to consider that yes, there can be some variability, but the biogas plant has to be designed for the region that it's set up in. Coming to the second point, yes, standardization of the spec of the end biogas is very important, because that can be controlled through the purification system, and definitely our company is playing one part in that, which is the H2S removal, and the other parts, I think that the methane content in the gas, the CO2 levels, all of that can be standardized, and they must be standardized, because it's very important that biofuel, or as we call CBG, needs to be of the right grade, whichever station it's at, so that the overall industry is something that can be trusted. And as far as the flexibility in feedstock is concerned, I would say that it's very important for the plant's biological health that they are not introduced to something that the culture cannot really take. So from my perspective, I've seen a lot of plant upsets because of the right feedstock not being available. So I would say that the term flexible feedstock does not go appropriately when it comes to a living organism, which is the digester. So the plant owners as well as the EPCs need to be very careful that what is introduced to the digester is something which will not upset it. So that being said, I think that the standardization part can come more towards the end product, not so much in the designing part.
Okay. Yeah. So thanks for your thoughts there. So now I would come to Gaurav. So Gaurav, with your experience in this field, uh, what do you think is the biomaterial that would be kind of very innovative in the upcoming 4 to 5 years, with the maybe anyways means whether it is a cow based or maybe from agro residues, whatever. So what do you think is the most innovative thing that will be striking the market?
That's a good question. I think the whole 3 days we are spending on it, but biomaterial has got a special place if you really see the whole gamut of bioenergy. All the time we keep saying that even though it's solid liquid gas, along with energy, you get something which is called biomaterial. In case of solid, when you burn it, you get carbon. In case of liquid, let's say biodiesel, you get glycerin. In case of biogas, you get fertilizer. But let's talk beyond this, because I think everyone is aware about it. Well, you talked about agricultural residue, and if I talk about paddy straw, which many of us would like to really look into it, and even though I take it through the traditional, let's say, cow dung route, because traditionally most of this paddy straw were fed to the cows, not as a substrate, maybe as a co-substrate, not as a main fodder, especially for the non-milching cows. And the beauty is that this straw normally used to get hydrolyzed in the stomach of the cow, and then in the cow dung what you get is the hydrolyzed paddy straw, so called. And there is something called alpha nanocellulose. I mean, it's the purest form of cellulose basically. You can extract out of it. It's a very, very, very expensive biomaterial, by the way. And it's not just a matter of research, it's already there in the market. I can tell you it can cost or give you more than 2,000 rupees per kg. So maybe, if I just draw the similar analogy, that biogas plant is a big stomach of a cow, and if I'm feeding paddy straw into it, maybe just looking from the fertilizer perspective will really not solve my financial dilemma. I think we should also look from, let's say, alpha nanocellulose perspective or pure cellulose in common man term. But what makes it even more interesting for me is this lignin part of it, because we can even think about, and this is a matter of R&D, it's not there in market through the biological source. We can think about graphene itself. Graphene, I don't know how many of you know it, just a single layer carbon, nothing else. But in coming 5 years, if you talk about hydrogen storage, if you talk about battery, if you talk about RO, if you talk about car body, if you talk about anything, graphene is going to change everything. Everything will be replaced by graphene. You can take my word. If you have not got anything out of this session, you should at least go and Google about graphene. I think this is where a lot of research needs to be done, and we can convert that into graphene. I mean, I'm not talking about graphene oxide or graphene hydride, but that is something can be looked into from biomaterial perspective. And I think this is something which can change the game, because people are still considering this as a headache, and that is a headache because you can't really even dispose of, forget about selling part of it, as far as the bulk of fertilizer is concerned, or fermented organic manure in the real terms. So I think biomaterial, and of course we can talk about bioplastic, we can talk about a lot of other things. I think we need to emphasize a little bit from that perspective as well, in order to really make it a viable option as far as the biogas or bioenergy is concerned.
Great. Thanks for those insights. And in fact, in the inaugural speech that we heard from our Honorable Minister, he also emphasized on bitumen being one of the products that comes out of the agro residues, and lignin is one such component which is aromatic in nature. So bitumen coming from that, although it is not chemically equivalent to what we get from the petroleum or the crude oil, but it serves the purpose. So that is one fascinating product that is going to kind of disrupt the construction industry going forward. So very well said. Now coming to Sanjukta, I think Gaurav emphasized a lot about research work, right? So we have been seeing a lot of research happening in this field, and at lab scale, a lot of products are getting established. But going through the pilot scale and the commercialization, a lot of products fail in there. So how do you think industry-led research, means research at an isolated silo scale that is different. But industry-led research, how can it change the scenario towards more commercializable products?
A very pertinent question you have raised. Since this is a biomaterial, one of the theme we are focusing on, I would like to focus on the way the biofuel sector gained the momentum. There is a huge potential for India also to look for development of technologies for biomaterials. When you say biomaterials, specialty biochemicals, enzymes, then bioorganic acids and the bioplastics. So if you see, India imports large volume of high value specialty biochemicals, specialty chemicals. Though the volume of import is less, but the value of the product is very high. So it is very much essential that we map our pathway for biofuel production, along with that produce some high value biomaterials. Having said that, then the biofuel molecule will one of the co-product we can consider. How? I can just cite some examples, the way we consider for the lignin. So lignin is a very good feed for the bitumen. Also lignin is a very good feed for production of high value pharmaceutical important product like vanillin. So it is essential to focus R&D and develop technologies for the product which has a high value in the market. And in many cases, especially for the chemical sector and some of the high value molecules, what is happening, the upstream production is being upscaled, but somewhere the downstream purification is also essential. There the research is not being progressing beyond TRL 3 or 4, but the industries are keen to take up those technologies only when these are being demonstrated at TRL 7. So many of the government funding is there for supporting the basic R&D, but the supporting for the translational research for moving this TRL 3 to TRL 7 is currently restricted or constricted. So it is very much essential to establish a industry academia joint hub. So one of the example that I would like to cite here, the Center of Excellence that was established in collaboration with Tata Chemicals. So this is a sort of biomanufacturing hub. So such type of hub can be created with the support from the industries, and India can identify whatever the portfolio of technologies are already there, which are being proven at TRL 3 and 4. Those technologies can be scaled up to TRL 7 through this, using these facilities, creation of the infrastructure facilities in this hub. And another thing is that the research should also focus innovative advanced technologies, because some of the specialty biochemicals that the downstream cost goes to the 60 to 70% of the overall cost. The market selling value is high, but the downstream recovery cost is also that very little critical. So technologies should be focused on development of low cost technologies so that the downstream recovery cost can be reduced, and all can be possible only through the creation of such hub or facilities, specific infrastructure facilities that can help in enhancing or showcasing these technologies at TRL 7. And one more, if you have some time, for the biogas, for instance, CO2 we are not looking at as a very good bio-commodity. CO2 is a very good commodity, but this should also be focused for production of biomethanol we were discussing, and also can be focused on high value, high pure precipitated calcium carbonate. If it is a very pure, then pharma has a high demand. So such type of mapping is required, which co-product we produce as a biomaterial along with biofuel, so that that has a high selling market and the overall process can be cost economically viable.
Great. So those were really insightful thoughts. So coming to Dr. Sangeeta, I believe your association with the biorefinery, so that is extremely fascinating, and I think the audiences would like to know about some of the products that your biorefinery kind of produces, and how easy or difficult it has been to create that awareness in the market wherein it is dominated by the conventional products, to kind of make use of such products. So little bit about the marketing strategy for these different products and the life cycle of these products as well, as you might have encountered in your refinery operations. So maybe something on those lines would be really insightful.
Yeah, so thank you for this question. And I just want to add one point is biorefining or biochemical is not new for our country. We've been making ethanol-based chemicals since many, many years. And I think today world is looking at where biomass is available. So apart from India, Brazil, and US, there is no other place. So if we are talking about bioeconomy, we're talking about maybe by 2030, it's going to be 25 trillion US dollars. Don't quote me by the number, but it's going to be big. So what we have to look at is where do we find ourselves? Because in India as a country, we are net importer of chemicals, biochemicals also. Now, when we are importing, and today we have excess of ethanol produced because of the policy intervention, we are at a very good space where we can convert this into very, very valuable products. They are not unknown chemistry. This is completely known. At Godavari itself, we make more than 25 to 30 chemicals out of ethanol. And today, world is looking at to decarbonize their embedded carbon. Because where do you kind of defossilize embedded carbon? Energy can only substitute 25 to 30%. If you only change the energy mix, you decarbonize by 25 to 30%. Rest 65% comes from embedded carbon. So let's look at that strength which our country has it as a biomaterial, biocarbon, and we must work towards retaining this biocarbon in the country, make value-added product, and supply to the world. Because I think we have the sun and the soil than a small farmer at the strength. Our research should start from the agriculture farms. We need to improve, as the panelist just before spoke about, we should focus on drip irrigation where we can improve our LCAs, we should improve our yield. This will all help us in decarbonizing, and I think if you look at the chemical space, it's a vast. Let's not focus only a specific, only CBG-based bioproducts. The space is very big. We can do a lot of things, but our technologies and innovation has to be also a step before. Now, why I'm saying this, we started this journey with our research institute together with cellulose derivatives and lactic acid, but China has surpassed us. China produces lactic acid and all bio-based chemicals in a big way. We must analyze why so. So I think this is a good food of thought, and there is a biomass available. We have technology institutes. Let's work together to make sure that we get to the world as a supplier of new materials.
Thank you, Dr. Sangeeta. So with these thoughts, I think it becomes very important for us to understand that why other countries have been doing well in the biomaterial, why not us, wherein there is a plethora of opportunity lying, at least in terms of the biomass that is there, right? So maybe we will understand from our panelists that what additional things could be done in the policy ecosystem, right? In terms of the policy intervention. Maybe one thought on the quick policy intervention. We'll start with Mr. Ravi first. So at central level or at state level, so whatever state you are operating at, maybe what policy interventions can make this ecosystem more conducive?
Yeah, very nice, actually very valid question over here. I will just put a light. Government has already blessed the farmer with, I can say, a subsidy on the crop residual management machineries. So now the subsidy is available on baler, rake, mulcher, slasher. This is available for the farmer who wanted to avail this subsidy over here. So this is widely spread pan-India across the states. The government is already given the policy intervention to encourage that biomaterials should be used for a wealth generation, not for the burning end. So that was already initiative taken, I think, some 7 years back, I just estimated. So it is already available over here. Now the second intervention we need is that government should support on fixing the biomaterial MSPs also. Okay. Yeah. That is going to be I can say a key factor where they will really, the farmer will really value what material is lying in the field. And with that, which Dr. Sangeeta and Dr. Srivastava had validly said, that kind of aggregate mechanism and multiplication of machineries are to be available, and with that kind of intervention by government and the private sector partnership has to be there, which will encourage them कि this material can be utilized a part of this. And second thought is that ki in the policy, a part of paddy, now, right now the policy is basically focused on paddy because we have a highly large cultivated field for the paddy. I will say it has to be drilled down to the niche segment also, where the cotton, groundnut and banana is also to be included. Because we go to the down south, that banana, and if you go to the south of our country, the groundnut is also available good, and coconut is also available good. If this kind of a policy is available, where the farmer can get ease out of the disposable income he will get from the crop residue, it will be very, very good. But if I talk about the fixation of MSP is already there, then fixation of crop residual MSP has to be also introduced by the government. That I appeal from this forum. Thank you.
Right. Santanu, your thoughts on needful policy interventions over and above what Mr. Ravi has already cited?
Yeah, I think sir has very rightly summarized all the points. I agree with them. And apart from that, I would say that there could be some policy incentives which can be for the biogas plant owners in terms of sourcing feedstock. Let's say if some sort of feedstock has a really heavy environmental impact, right, in terms of the benefit it's providing when it's being digested by that biogas plant. It could be a little complex based on the region, but see, whenever a feedstock is coming from a far away region, that's also having some sort of impact in terms of the carbon emissions that are going into the environment. So I see that regionality needs to be rewarded when it comes to feedstocks. This will add and increase the profitability also for the biogas plant, but at the same time it will make sure that we are really giving back to the circular economy. We are not driving away from that. And at the same time, I would say that when it comes to policy interventions, we can look at different technologies which are good for the environment, and that is more towards the biogas plant side. But when it comes to the aggregation and the farmer side, I think that one of the very important things is for some sort of price mechanism that can be put in place that will secure the biogas plants as well as the farmers in future.
Thanks, Antanu. So that idea of the carbon taxation that you said, to kind of take into account the overall carbon cycle, that really is fascinating. And we are already seeing that being implemented as this carbon border tax being implemented in Europe. We have been admonishing that policy, but that is something that is the need of the hour if we need to push this biomaterial or the sustainable biomaterial through into the ecosystem. Gaurav, your thoughts on policies, any, if any?
So, I think a lot has already been talked about policy. It's better said than done. So I think from government perspective, if I see from their lens, number one, they should think about bottom-up kind of policies, not top-down. That is very important, especially in bioenergy field. Number two, I think they should really do a proper analysis from the impact perspective as far as the policy is concerned, instead of just getting pressurized from the international lobby. I'm just not naming anyone, but I think it's something which is the demand of the time, that we need to be a little selfish in a manner. When we talk about Atmanirbharta, then we really need to be Atmanirbhar also from policy perspective. We should not just copy paste the policy. Number three, as I also mentioned, that the policy should be based on the demand side thing, not just the supply side thing, because I think this is something which is very confusing. If I'm able to sell liquid fertilizer, liquid fermented organic manure in my vicinity, let's say in Kanpur, perhaps the guy in southern India also, he will try to do the same. I think this is where the state level policies, etc., also come in picture. So anyways, India has got this federal structure. So we need to think in a very localized fashion. And the state level policies should also interfere and try to analyze what really works in a very localized fashion. And then they can incentivize. And when I say incentivize, I don't only mean money. They can be incentivized in many ways. I mean, someone talked about accelerated depreciation. We can talk about tax holidays. We can talk about X number of things. I'm personally not a big fan of giving money all the time. If you want to give it based on the performance, not upfront. Again, it's a sensitive thing to talk about. That's why this kind of study is needed, which will really cater the thing in more bottom-up manner.
Thanks, Gaurav. So, Dr. Sujukta, specific question to you with respect to this BIRAC centers, for which a fund has also been allocated, almost 3,000 crores. So what additional you think is needed to be done in order to promote this ecosystem even further?
Very rightly said. The way the policy was rolled out for biofuels, because if we see the goal of achieving net zero, that holds true for all the industries, including the chemical industries. We do not see any such policy for the chemical industries, how much portfolio of their molecule be required to be green at different time frame. But one of the very good, this Bio E3 policy that was rolled out by Department of Biotechnology, Government of India, that creates a funding as availability portfolio or providing that platform for scale-up of processes for biochemical production. That is for the R&D support. Like Gaurav has mentioned, creating demand is very much essential, and for net zero goal, it is very much essential that such type of policy should be rolled out for the chemical industries. And another point I would like to focus here for the CBG especially. The policy is there, we are talking of our bio-CNG, blending in CNG and all. Similarly for the FOM inclusion in the creating a blend of FOM based fertilizer that can give advantages for multiple segments, reduce the required consumption of urea. And when you see for reduction of consumption of urea, then consumption of requirement of hydrogen is also less, and also enhancing the soil fertility. And these are the multiple factors. And another impact is rolling out of credible carbon pricing that will create a push for the bio industries, be it the CBG, be it the bioethanol. CO2 is coming out as an additional biocommodity that will create a push to capture this biogenic CO2 and use as a value-added molecule for, let's say, biomethanol or because going forward for the maritime sector also requires the green molecules. So we must look into the factor that the policy is drafted in such a way each fraction of the co-product which is coming from the process is needed to be integrated as a feed for some other product. The holistic drafting of policy.
Very well said. So Sangeeta, finally coming to you, how do you see the ecosystem right now, policy ecosystem, and what kind of interventions do you think, apart from what has been already cited?
So I think most of the things have already been talked about. What I can only say is, like, I think we've seen the success of ethanol blending program. Somehow for the biochemicals and bioproducts, we need to introduce some policies because we cannot be dependent on the fossil feedstocks because volatility is high. As a country, we have resources. Some policy pull and because there are three factors which are important for any biochemical to go is your customer requirement, which we don't see in our country because today we sell our biochemicals mostly outside country because today, as we are growing economy, we are not looking at where my carbon is coming from. So basically, we are looking at cheaper resources for our larger population. So that's fine. But for the government mandate, it is important because unless we put in there, these products will not see that light of the day. So it is important that we have some kind of policy intervention, which was there for ethanol program, for biochemicals as well, and bioproducts and biomaterials. I think a lot of things are happening. I see in some of the states where they're offering very good funding for biochemicals. I think in IGL is producing ethylene glycol, and we have PLA projects coming up. So things are happening, and this will come with government intervention only, because we don't have customer pull here.
Very right. So for sunshine industries like this, definitely government intervention plays an important role to kind of give it the required push. And then the ecosystem grows, and then we can think for the financial institutions or the investors to kind of put in money to make it even more robust. So thanks to my esteemed panelists. It was a wonderful discussion. We can keep going, but I have been signaled that I need to wrap this up, right? So maybe we can take a question or two, or is it time to wrap? So maybe if, I think, yeah, guys are already drained out, but if you have a question or so, maybe you can direct it to the panelists. Or maybe we'll take it offline, yeah. So thanks all. So thanks all for your participation, and thanks audience for your patient listening. Thanks all.
Thank you so much. A big round of applause for this wonderful thematic panel session, the last panel session for day 2 on the topic biomaterials, plethora of opportunities and possibilities. We can definitely give a big round of applause to all our esteemed panelists. Thank you. Thank you so much. We can clap for ourselves as well. And now I request our moderator, Mr. Abhijit Mukherjee, to kindly felicitate all our panelists. So we request you to kindly honor Dr. Sangeeta Srivastav, Executive Director, Godavari Biorefineries. Thank you so much, ma'am, once again for your valuable contribution to the session. Thank you for sharing your insights on biomaterials. We now request you to kindly felicitate Dr. Sujukta Subudhi, Associate Director, TERI. Thank you so much, ma'am, for gracing the occasion. Thank you for your enlightening thoughts. We request you now, sir, to kindly felicitate Mr. Shantanu Agarwal, Executive Director, Bharti Waters Private Limited. Thank you so much, sir. We now request you to kindly felicitate Mr. Ravi Mathur, President, Tirth Agro, Shaktiman. Thank you so much, sir, for your contribution to the session. We now request all of you to kindly come forward for the group photograph. Ladies and gentlemen, with this we conclude the last thematic panel session on biomaterials, plethora of opportunities and possibilities. That also brings us to a close for day 2 event of 5th edition of BBB International Expo and Summit 2026. Thank you so much. Once again, we thank all our panelists. We request all of you to kindly join us over networking, tea and coffee. Wish you a great evening ahead, and see you tomorrow for day 3, the final day of the 5th edition of BBB International Summit and Expo 2026. We thank all our supporting partners here. It's a privilege to associate with you all. We thank our silver partner, Gale India Limited, Lanyard and Badges partner, Gruner, Tea and Coffee Break partner, Indian Oil Adani Ventures. Thank you so much. See you tomorrow.